Hi students. So after learning the Laplace transform of integral property, we are going to start with the numericals based on Laplace transform of integral theorem. So here we will see different numericals and let's understand how to apply that theorem in the numericals to get the value of Laplace transform of given function of t. So here we have to find out Laplace transform of integration 0 to t u square sin u du. Now guys, just looking at the problem, we come to know that this question is from Laplace transform of integral, because you must be knowing that in Laplace transform of integral we always have integration from 0 to t. So here Laplace transform of integration and integration limits is from 0 to t. It denotes that we have to solve this problem by Laplace transform of integral. So before starting the solution, let's see what is the Laplace transform of integral. So here on the screen you can see that if Laplace transform f of t is phi of s, then by the Laplace transform of integral, Laplace of integration 0 to t f of u du is given by 1 upon s phi of s. Now guys, don't get confused between f of t and f of u, because here we are going to consider this f of u as f of t only. Because see, since the limit is from 0 to t, let's say if I evaluate this integration and if I put lower and upper limit, then lower limit is 0 but upper limit is t. Therefore my function is gonna get converted into function of t. So while finding the Laplace of this function, I'm gonna consider this f of u as f of t. So from that f of t, I'm gonna find out Laplace and I'll treat it as phi of s, and that phi of s is nothing but the part of my answer. So my answer will be 1 upon s phi of s by the property of Laplace transform of integral. Now guys, what happens, sometimes we get double integration or triple integral. So in such cases we have to use 1 upon s raised to n into phi of s formula, because here n denotes number of times you want to integrate or number of times the integral given in the question. So basically this will be your question and this is gonna be your answer. So many times it happens that in the question itself they give you 2 integrations or 3 integrations from 0 to t. So that time what we have to do is we have to use s raised to the power which is equivalent to number of integrals in the question. So this is the property. So guys, if you see here, then 0 to t and this u square sin u, I can call it as f of u. So as I said you that we are gonna treat that f of u as f of t only. So here I'll say f of u or f of t is t square sin t. And guys, we are gonna find out the Laplace of this f of t, because Laplace of f of t is gonna be phi of s and I'm gonna use that phi of s to find out the answer. So let's find out Laplace of this. So Laplace of f of t is nothing but Laplace of t square into sin t. Now to get the Laplace of this t square into sin t, how to get the answer? So guys, again here if you observe the term carefully, then it is nothing but multiplication by t theorem, because here I can consider this sin t as my function and it is being multiplied by t square, so it is matching with multiplication by t property. So let me show you that as per the multiplication by t property, we have t raised to n into some function of t and the answer is given by minus 1 to the power n d to the power n ds to the power n phi of s, where phi of s is Laplace of that function of t. So accordingly here now I have t square, so this will become minus 1 square d square ds square phi of s, and phi of s is Laplace of f of t and f of t in our case is sin t, so that will be Laplace of sin t. So let's apply it. So here I'll say using multiplication by t theorem. So by this theorem we will get answer as minus 1 square d square ds square into phi of s, and phi of s is the Laplace of sin t. So Laplace of sin t is 1 upon s square plus 1, that we all know. Now guys, let's find out the derivative of this function and get the value. So now minus 1 square is 1, and since here I have to find out the second order derivative, let's find out first derivative. So I'm keeping 1 d by ds outside, and I'll apply or I'll find out derivative of this function for the first time. So what is derivative of 1 upon s square plus 1? It is similar to 1 upon x. So the formula for derivative of 1 upon x is negative 1 upon x square. So this will become minus 1 upon s square plus 1 the whole square into derivative of this, that is 2s. Next I'll take this will become minus 1 into 2s. So I'll take this minus 2 outside. So here we will get it is equal to d by ds of s upon s plus 1, I mean s square plus 1 the whole square, and let's take that minus 2 outside. So let's say minus 2 here. Next minus 2 as it is. Now to find out derivative of this, here in the numerator denominator we have s term, so I'm gonna use u upon v rule. So by u upon v rule, here we will get first term is v, that is s square plus 1 the whole square, into derivative of u, so derivative of s is 1, minus u, that is s, into derivative of v. So derivative of this is 2 times s square plus 1 into 2s upon v square. So square of this is s square plus 1 raised to 4. Now guys, let's simplify this. So this will become minus 2. Now from the first and second term I can take s square plus 1 common outside. It will be cancelled with this s square plus 1, and here we will get s square plus 1 cube. So guys, here I'll write it down for you. So in the denominator s square plus 1 the whole cube. Now let's say in the numerator. So in the numerator, from s square plus 1 the whole square, one term is gone outside, so only s square plus 1 remaining. Next here, this s square plus 1 has gone outside, so 2s into 2s is 4s, so I'll say it is minus of 4s. So here we will get minus 2 in bracket s square minus 4s plus 1 upon s square plus 1 the whole cube. And guys, this is nothing but my phi of s, because this is the Laplace transform of this f of t. So Laplace transform of f of t is phi of s, hence I call this as phi of s. Now guys, as I got Laplace transform of this t square sin t, which is nothing but u square sin u, now I can apply the Laplace transform of integral. So by Laplace transform of integral, here I'll say the Laplace of integration 0 to t u square sin u du is equal to 1 upon s into phi of s. So value of phi of s is this, so that will become minus 2 into s square minus 4s plus 1 upon s square plus 1 the whole cube. And guys, if we write it properly, then we will get minus 2 upon s, that is minus 2 by s into s square minus 4s plus 1 upon s square plus 1 the whole cube. And this is nothing but Laplace transform of given function. So here we got the value for given function. Thank you very much.